Hi, good morning everyone. Differential equation topic is going on. Last class I have taken this homogeneous differential equation. I told you how to identify homogeneous differential equation. Let me take some more example of this homogeneous differential equation. Now see, I am taking question number 1, this one, that is x into dy by dx and then into sine y by x or plus x minus y sine y by x equal to 0. Okay, fine. Anyhow, sine y by x. You see the question, you can confirm it. Yes, it is a homogeneous differential equation. First of all, you try to bring the equation into dy by dx equal to something. So dy by dx is equal to this terms goes to that side, y sine y by x and then minus x the whole upon now x into sine y by x. Clear to you? Now see, take out numerator from denominator, algebraic term, the degree of numerator x. Now at x I am taking out to common, x into sine y by x minus 1 the whole upon x into sine y by x. Clear? It will be cancelled. Now I am giving substitution y by x is equal to v. Every questioning how to follow same steps. This implies y equal to vx. Now if you differentiate dy by dx is equal to v plus x into dv by dx. Now substitute everything here. So that is a v plus x into dv by dx. That is equal to v sin v minus 1 the whole upon sin v. Now do it variable separable, x into dv by dx, that is equal to v sin v. If I take this minus v, if I take LCM minus v sin v the whole upon sin v. Clear? Now it will be cancelled. Now I am going to do variable separable. What we collect all v and dv one side. So dv upon that is dv sin v into dv, that is equal to sin v into dv. I am doing variable separable, that is equal to minus dx upon x. Now take it integration both sides. So this implies what we are getting, minus cos v equal to minus log x. I am writing minus log c. So if I cancel throw to this minus cos y by x, that is equal to log x plus log c. Okay, fine. If you want do plus c, simply minus c, or log, if you want write log, you can, so that you can write log cx. That is up to your choice. Okay, fine. So then even you can write cx is equal to, now let me see the initial value they have given here. What is it given? Y of 1 equal to pi by 2. Now the value of x is 1, y is pi by 2. If I substitute here cos pi by 2, so that is equal to log, I am getting c. Am I correct? The value of x is 1. Now log cos 90 becomes what? 0. So that is equal to log c. This implies c is equal to e power 0, that is equal to 1. So the value of c is 1. Now therefore this implies cos y by x, that is equal to log x, that is equal to log x. The log c value is 0. Now this is our final particular solution. This is called what? Particular solution. It is so simple, homogeneous differential equation. So what I told you, you have to check. If it is algebraic function, you have to check degree of differential, degree of each term. If it is equal, automatically it becomes homogeneous. If you want to make a confirm, you can confirm here, therefore it is homogeneous. After this step, you can write it as homogeneous. Clear to you? Okay, fine. No need of taking lambda, this, that. Okay, now let me take one more example. Then after that, I will start another topic. Okay, now see. Next question I am taking for homogeneous and different format I am taking. So that is the question is 2y into e power x upon y. Now see, throughout the equation the term is x upon y. Then you have to change a little bit, bring the differential equation into dx by dy equal to something. dxy. So throughout divide by dx by dy. Throughout divide by dy. Now plus y 2x e power x upon y equal to 0. This implies dx upon dy, that is equal to 2x e power x upon y minus y the whole upon y 2y into e power x upon y. Now take out, you take out y from numerator. See, highest degree of x. Generally we used to take in x by y format highest degree of x. Here you have to take highest degree of y. That is the difference. Bring the format dx by dy and then take out highest degree of x. Unless until if they have given x upon y format, then only you go. Otherwise, you have to follow previous one only. Clear to you? Now see, I am taking out x here. So 2 into x upon y, e power x upon y minus 1, the whole upon 2y into e power x upon y. It will be cancelled. Now I am giving substitution x by y equal to b. This implies x is equal to vy. Now dx upon dy, that is equal to v plus y into dv by dy. The same step, we are differentiating with respect to y, that is the difference. Now v plus y into dv by dy, I am replacing here all these steps. So 2 into x by y, v into e power v minus 1, the whole upon 2v. If I take variable separable, I am collecting all. V is one side. If I take this side, that is 2 into e power v. Okay, 2 into e power v. Now y into dv by, this is one of the most important board question, this one. So that is 2v e power v minus 1 upon 2 into e power v minus v. That is equal to 2v e power v minus 1 minus 2v e power v, the whole upon 2 into e power v. It will be cancelled if I take variable separable. So e power v into dv, that is equal to 1 upon 2 into minus 1 upon 2 into dy by y. Now take it integration both sides. So that is e power v integration is e power v minus 1 upon 2 into log y plus c, that is up to your choice. Now this implies e power y upon x, that is equal to minus 1 upon 2 log y, or plus what is it, c. If they give an initial value, substitute to find the value of c. So this is another format in homogeneous differential equation. So what I told you, first you identify homogeneous differential equation, whether it is homogeneous or variable separable. First, if they ask a solve differential equation, you have to give priority first to homogeneous. Check degree of each term. If it is equal, confirm it is homogeneous, then follow all these steps. Now let me introduce another topic. This is the last topic, and then one extra format is there, that's I will give you. Now next I am taking, already we have seen formation, variable separable, and then homogeneous. Now let me start the format first order linear equation. First order a linear equation, a linear differential equation. Okay, fine. First order, what is first order linear differential equation? First let me brief. Now format number 1, dy by dx plus p into y equal to q. See, let me explain. Where p and q are constants, or other way, or terms in terms of functions in terms of functions in terms of x. Clear to you? Means you will get only single y. Except this y, you will not get any y terms. This is identification I am saying, how it becomes first. How can you identify first order linear equation? That linear equation contains only one algebraic y. Rest of the terms are either constants or functions in terms of x. Y terms will not repeat once again. Okay, fine. Now how to relieve this, how to solve this differential equation. Now see, step number 1. Coefficient of dy by dx. Coefficient of dy by dx is 1. Suppose if any coefficient here, then throw to divide by this. Now step number 2, identify what is a p and what is a q. Okay, fine. Now step number 3, p is coefficient of y and q is equal to whatever given, that is a q. Now step number 3, integrating. Sometimes they will ask one more question, find the integrating factor. Integrating factor, that is simply denoted by if, e power integral p dx. When you are doing this step, one thing keep in mind, suppose if it is e power log x, you can write x. Suppose if e power minus 2 log x, you cannot write minus 2x, this is totally wrong. So first you have to take this power e power log x square, that is I am using the formula n log m power n. So now e log cancel, that is equal to x power minus 2, 1 upon x square, entirely different result. So keep this all the points at the time of doing integrating factor. Step number 4, solution. So what is the solution? So y into, if it is dy by dx, so y into integrating factor equal to integral q into integrating factor into dx plus c. This here you have to use by parts. This is there are two functions within product. Integrating factor you have. So q into integrating factor. So here you have to use which one? Integration by parts. That's why I told you how to learn which one, partial and integration by parts. The same we have another format number 2. So that is dx by dy plus px equal to q. The same here, p and q are constants, or otherwise constants are functions in terms of y. So what is identification? How to identify? I told you have to solve. If they ask solve differential equation, give priority for homogeneous. If it is not homogeneous, then switch over to this first order linear. How can you identify this first order linear? What I told you, if there is a single y, rest of the terms are functions in terms of x, otherwise the constant. Beyond this y, you will not get any functions in terms of y. That is dy by dx plus py equal to q. And if it is in this format, then you will get only one algebraic x. Other than this x, you will not find any x terms here. That is dx by dy plus px is equal to q. Now how to solve this one? The same coefficient of whatever I have written previous, coefficient of dx by dy is 1. Step number 2, you have to identify what is the p and what is the q. And step number 3, integrating factor if, that is equal to integral p into, that is a dy with respect to y means with respect to y. At the same time, you remember all these steps. Now step number 4, x into integrating factor, that is solution. X into integrating factor equal to integral q into integrating factor into what? Dy plus c. But that is difference between these two formats. So we have first order linear equation. There are two formats I briefed here. Now let me take example of both this topic. Then differential equation, we have one special format. That's I will give you some example of this special format how to use. Now let me take another example, that is the first order linear equation. I am taking question number 1, dy by dx plus y cot x equal to 2 cos x. Okay, fine. Now see, this is first order linear equation. You confirmed it. It is not a homogeneous equation. Okay, because here there is no y by x, here there is no y by x. Single y, that is dy by dx. Coefficient of dy by dx is 1. Now what is the p here? Cot x. And what is the q? That is equal to 2 cos x. Now integrating factor, so that is equal to e power integral p dx, that is equal to e power integral cot x into dx. Now that is equal to e power log, we are getting sin x. Okay, fine. Now e log cancel, so final integrating factor, that is equal to sin x. Clear? Now solution, so that is y into integrating factor equal to integral q into integrating factor into dx. Now y into integrating factor is sin x, that is equal to, what is the q? Q is this, that is integral 2 cos x into integrating factor sin x into dx. Now you know this is y sin x, that is equal to integral, you can write even sin 2x into dx. Sin 2x integration is, that is equal to y sin x, that is equal to minus cos 2x upon what we will do plus what? C. If they have given initial value, substitute here, get value of c. This is our final answer. It is so simple, first order linear. Now let me take another example. Another example I am taking, that is question number 2, 1 plus x square into dy by dx or plus 2xy, that is equal to 1 upon 1 plus x square. Anyhow, again this is first order linear equation, that is single y, so dy by dx. The coefficient of dy by dx is 1. Now I am dividing through by dy by dx plus 2x upon 1 plus x square into y, that is equal to 1 upon 1 plus x square ka whole square. Now what is the p? P is 2x upon 1 plus x square, and what is the q? 1 upon 1 plus x square ka whole square. Now integrating factor, so that is equal to e power integral p dx, that is equal to e power integral 2x upon 1 plus x square into dx. So that is equal to e power. Is the differentiation we have, numerator differentiation is numerator, we can write log 1 plus x square. So that is equal to 1 plus x square. Clear? Integrating factor. Now final solution. Y into integrating factor. What is integrating factor? 1 plus x square equal to integral q. What is a q? 1 upon 1 plus x square ka whole square into integrating factor 1 plus x square into dx. It is so simple. This is integration of 1 upon 1 plus x square is tan inverse x plus c. They have given initial value y equal to 0 and x is equal to 1. If I keep y is 0, total term is 0. Now that is equal to tan inverse of 1 plus c. So this implies tan inverse 1. What is tan inverse 1? Pi by 4. This implies c is equal to minus pi by 4. So therefore particular solution what we are getting y into 1 plus x square, that is equal to tan inverse of x minus pi by 4. This is also another most important question. Are you clear how to solve this first order linear equation? Now take it one more example of this format. That is another question I am taking here. Now see this one. I think you are clear for this topic. Okay, the step is the same. Okay. Now see this one, another one. This is a tan inverse. Tan inverse x minus x into dy equal to 1 plus y square into dx. So anyhow, I am relieving this. First I am collecting dy by dx, that is a tan inverse x minus x into dy by dx, that is equal to 1 plus y square. Okay, fine. See now, you have to identify this is which format. This is tan inverse x, this is x, this is 1 plus y square. I hope so this is tan inverse y, otherwise it is quite impossible to find its first order linear differential equation. Tan inverse y minus x into dy by dx equal to 1 plus y square. Now see this format is, there are single x. Now this is a single x. Now suppose if I take this one as y. Now single x, this is also the format as a dx by dy format. Now what I am doing, tan inverse of y minus x, that is equal to 1 plus y square into dx by dy. Why I brought this format? Because the differential equation, this is not homogeneous, degree is not symmetric. Now this is single x terms, of course this becomes dx by dy format. Now 1 plus y square into dx by dy. Now I am taking this x term also that side plus x, that is equal to tan inverse y. Now see, I brought the format dx by dy plus px equal to q. Now step number 1, coefficient of dx by dy is 1. So now dx upon dy plus x upon 1 plus y square, that is equal to tan inverse y upon 1 plus y square. Clear? Okay, fine. Now what is the p? P is 1 upon 1 plus y square and q is tan inverse of y, the whole upon 1 plus y square. Okay, fine. Now integrating factor, that is integrating factor. So that is equal to e power integral 1 upon 1 plus y square into dy, that is equal to e power tan inverse y. Okay, fine. Now solution. So what is solution? X into integrating factor e power tan inverse y, that is equal to integral q. What is the q? Tan inverse y, the whole upon 1 plus y square into e power tan inverse y into dy. I am giving substitution tan inverse y equal to t. So this implies 1 upon 1 plus y square into dy equal to dt. So you must know integration little bit for solving this differential equation. So this is a t and this becomes, what is it, dt, dt, and this becomes e power t into dt. Of course by parts, this is first and this is second function. First function into integral of second function, can you remember, by parts minus integral. Differentiation of first function becomes 1 into integral of second function into dt. Now t e power t minus e power t plus c. So x into e power tan inverse of y, that is equal to, would replace t by tan inverse y, e power tan inverse y minus e power tan inverse y plus c, or otherwise substitute initial value x is equal to 0, y equal to 0, x is 0, totally 0, tan inverse of 0 becomes 0, e power anything e power 0, tan inverse 0 is 0, e power 0 is how much? 1. So this implies the value of c is 1. Therefore particular solution what I am getting here, so that is x into e power tan inverse of y equal to tan inverse y e power minus tan inverse y minus e power tan inverse y or plus 1. If you want a final answer, you can do divide through by this tan inverse of y, tan inverse of y and minus 1 and then plus e power minus tan inverse y. Clear to you? This is your final answer. It is so simple. So first order linear equation I have given two types of format. One is dx by dy plus px is equal to q. Identification I told you single algebraic x. Other than this algebraic x, you will find y terms only, not x terms. If it is a dy by dx, then you will find only single algebraic y. Not other than this y, you will find x terms. It functions in terms of x and not y terms. Clear to you? So I will give you one or two examples more. Do practice. Stay blessed. Thank you so much.